Okay, so now that we know what acids and bases are, the new thing is what happens to an acid when it reacts. So if you're an acid, it means you walk around all day with a hydrogen saying, would anyone like this hydrogen? Please let me give you a hydrogen. And that if you find a taker, if this NH4 meets someone who says, why, yes, I will take one of your hydrogens, then afterwards, two things. First, the number of hydrogens in this species will go down by one. So instead of NH4, we'll have NH3. And because the hydrogen that we gave away had a positive charge, giving one away costs you one positive charge, so your charge goes down by one step. So here, instead of having a charge of +1, the charge will just be 0. And so NH3 would be the conjugate base. This is the before picture, and this is the after picture. It's not necessary to write this if you're talking about a conjugate base. I just put it there to remind you that that's what's breaking off. So a single hydrogen goes away and your charge goes down one step. Here, if we lose one hydrogen, then we have none left. We just have SO4. And the charge goes from -1 down one step to -2. Remember, chemists write the sign after the numbers, so 2 minus, not -2. Weird but true. And here, a hydrogen comes off. We're left with PO4. No H's to speak of. The charge goes from -2 to -3. Not too bad. With bases, the exact opposite is true. Bases walk around all day saying, could anyone give me a hydrogen? I would like one more hydrogen. So if a base succeeds at getting a hydrogen, its hydrogen count will go up by 1 and its charge will go up by 1. So H2PO4 would turn into H3PO4. And the charge goes from -1 up to 0. We don't write zeros there, so we just leave that blank. The cyanide ion, if it gains a hydrogen, well, now it has one, so it's HCN. Hydrogen's a positive ion, so it goes first on the list. And again, charge goes from -1 up to 0. And if carbonate gains a hydrogen, it becomes HCO3. And the charge goes from 2 negative up to just negative.